Okay, this video is for Kris with a K. I'm working with two Krises at the same time here. I believe it's with Tubular something. I can't remember your company name, but I want to show you what 200 degree water looks like here, just so we're on the same page. And as you can see, it does start to boil. I'm going to try and keep it at this temperature. It's going to be hard to do that. We're only at 201 degrees there, and as you can see, some of those bubbles are reaching the surface. And despite the textbook proclaiming 212 degrees being the boiling point of water, you can see we would have a significant vapor pressure. Now, as far as your water tank's concerned, I have not seen a photograph of this tank, so I can't tell you whether or not this is going to be an issue. If the tank is enclosed on the top, you're going to have pressure buildup. It's very hard to keep this right at 200, but you get the point. We're probably going to not hit the mark, if you know what I mean, very easily. I have a stove here, and I'm going to do my best to keep it at 200 degrees exactly, just to kind of show you. Like, we're obviously going to have the tank at 203 degrees at certain points in the operation. It may not be avoidable without some sophisticated thermocouples and stuff like that, or thermostat setup. I'm trying my best to turn this heat down here. So that's what 207 degree water looks like. So if we don't have a vent on your tank, you're going to pressure up, obviously. Okay, now let's get to the second part. If you don't have an enclosed tank, this amount of steam is going to add up over hours of operation. I don't know the duration of your process cycle. That was a question I forgot to ask you. How long does the system run? And for the most part, as you can see, hitting a target temperature of 200 degrees is kind of possible. It's hard to do. What'll happen is we're just going to come so close to the boiling point sometimes that you're going to be producing a lot of steam, and we would want to incorporate some kind of condenser bulb that would allow this steam to rise up into the condenser bulb, turn back into water, and reflux right back in to the system. Or a reflux bulb, I guess is what you would call that. So essentially, Kris, this is a design that I recommend that may be a little bit easier to do than your tube system, because in the long run you're going to have to clean that heat exchange out. No matter what type of burner you use, soot buildup is going to line the walls, and it's going to inhibit the transfer of heat, and it's just going to cost you a lot more money to heat this tank up. So I suggest a setup like this, where you have the burner in the center and you have these baffles under the tank. This tank could be set up on bricks, and these baffles could be made out of fire bricks in themselves. We don't have to weld walls to the side of your tank, but putting the flame in the center cuts back on the waste heat on the exterior there. And it's not going to bother anything with this just discharging right out the side like this, as far as a flue is concerned. If it's outside and away from anything flammable, your discharge temperatures are going to be around 300 degrees or so in this setup. But what I was getting at about the vapor coming off the water is that if we were to take some kind of a piece of tubing, say, you know, a 1-inch line or something, and connect it somewhere to the top of your tank, and then draw it away at an angle here, and then up at the top we would place like a condensation bulb, which would typically not look anything like this, but just to give you an idea of what I'm getting at, any vapor pressure that builds up in your tank would rise up into this bulb, cool off, and then turn back into liquid and drip right back down into the boiler. Even though we're not operating at boiling temperature, there's going to be some significant pressure up, and this may become an issue This bulb may end up having to be a radiator with a fan on it. Or you could just vent it out to atmosphere. The only problem with that is someone will have to monitor the tank level because you're going to boil down, which may not be all that big of a deal. All I'm getting at is that we will have to vent this tank. If it's not an open top tank, we're going to have to vent it. If you are worried about the water loss, like let's say this thing just runs all day and you don't want to keep adding water, we could put some type of float in the tank. But the problem with trying to run a float in a tank like this is if it's boiling at all, the float might not act properly. But there are some other little details when you get right down to it that are going to crop up. So if you could just tell me how long the boiler runs at any one point, or the water heater I should say, and whether or not your tank has a top on it, I could definitely get us headed down the road with a lot more accuracy. I think that if the top of the tank is open, that's not going to be all that big of a deal. We would definitely want to cover it. I mean, you don't want just anything landing in there, obviously. So hit me up with the tank and let me know what you think about this bottom baffle design. Like I said, for the most part, a lot of this could just be bricks, just properly placed. We don't have to weld these baffles in place. This is basically an underpan where the water would sit on top of this section of the burner. And this right here is a new wind resistant burner that I've been working on called the Godzilla burner. I'm getting ready to cut some out of some real good high grade stainless steel right now. I have tested this burner extensively. This is a steel one, made out of steel. And I wouldn't sell you this one because it will eventually burn itself up. As you can see, it's already started to do that. But this particular type of burner is the most wind resistant burner I have ever seen. This thing was working, it burned a tree stump out of the ground in gale force winds. It was like blowing wind. So I was very impressed with that. This is the design that you had in mind. This is a heavy-duty stainless steel version. The problem with this type of burner, for whatever reason, it goes out in the wind. It doesn't work well in windy conditions at all. So it's unreliable in the wind. And I don't want to sell you one of these if your burner is going to be outside. Now, I heard that you mentioned you were going to cover the burner up. If you would prefer this burner and you did intend to build an enclosure, this will work perfect. However, I still highly recommend you wait till I finish building your stainless steel version of this particular unit. This is called the Dragon, and this is Godzilla. Sorry for the retarded names, but just the first thing to come to mind when you look at the flames, you know. So basically, this is the type of burner that is so much easier to light. As far as there's different angles of attack involved with these nozzles on this particular burner. Having the angle is so important. This one here, you throw the thing together, you keep the nozzle about 1 millimeter away from the face like this, or 2, and you're ready to roll. It lights like a candle. This here, it turns out I'm a professional at lighting them. It's not a problem for me, but a couple of my customers have told me that it took them a while to figure it out. Once you figure it out, it's easy. But there's a learning curve there. This one here, there's no learning curve. You light it and it lights. As far as temperature, this one was capable of putting out above 2,400 degrees Fahrenheit. This one is right around 2,350. So it's 50 degrees hotter for whatever reason as well. So that's another thing that me and you need to discuss. The version you would be getting of this will have a dual nozzle setup, because the tank that you're trying to heat up is fairly large. You're going to want one of my 500 kilowatt versions. They only run 500 kilowatt on diesel. The waste oil figures are different because of the viscosity.